right, guys. On Friday, we worked on kind of going back and forth between the two forms. Today, we're going to have some instances where we need to switch back and forth between the two forms, or we can just kind of simplify where they're at. Sometimes it depends on your preference, what you're more comfortable with, which form it's in. All right, so number 19, we are just working on simplifying now. So we have 216 to the 1/3 power. What does that mean? If I would flip that back into radical form? Good. That means that is the cubed root of 216. Is the cubed root of 216 perfect? What is the cubed root of 216? 6? Do you guys agree with Marcus? Was he right? Yes, he was right. Did you? All right, but noticing when you see it 216 to the 1/3 power, it looks kind of weird. But if you flip it into the third root of 216, you're like, oh yeah, I can do that one. You know, it makes more sense that way. All right, so 49 to the 1/2 power, what's that mean as radical form? Good. Square root of 49, which is 7. All right, 21 x to the 5/4 power, what's that mean? Good. That's the 4th root of x to the 5th. Can you simplify that? Can you do a group of 4? Good. How many groups of 4 can you get from here? How many left over? Don't forget that index of that 4 when you rewrite that. Okay, but yeah, so flipping back to radical form makes more sense. You're looking for groups of 4. You can have one group of 4 to pull out, and you have one left over. All right, number 22, 8 to the 2/3. What's that mean? Cubed root of 8 squared. What is 8 squared? It means 64. Can you do this cubed root of 64? What is it? It's 4. Good. Okay, so those are 4 problems where it was listed with an exponential form, but it made more sense if we flip it back to radical form before we deal with it. All right, next we're going to look at a real quick review. We did exponent properties way in the beginning of the semester, just to kind of refresh your memories here. If you are multiplying your problem and the bases are the same, your exponents, we add them. Something like this where you have the parentheses, this is where you would distribute, right, your exponents, and they multiply exponent to exponent. Same thing here, it's just, again, you would distribute to both parts. So a to the m, b to the m. Over here, negative exponents. Do you remember those? Negative exponents, you have to, it pushes whatever it is to the bottom of the fraction. What if it's negative in the bottom? Where does it go? It would move to the top. The negative exponent moves it. It causes it to move. Okay? And once you move it, then it would become positive. If it's a division problem, what do you do with your exponents? You subtract them. And same idea here, you have that outside the parenthesis, you would distribute. It just distributes to both top and bottom. But we've seen these properties before, yes? Okay. All right, because now we got crazy looking stuff like that. Right? All right, so we're going to use our properties to kind of condense these a little bit, and then we can rewrite them into the form that we're comfortable with. All right, so 18 to the 1/3 times 18 to the 1/3 times 18 to the 1/3. What do I do with my exponents? It's a multiplication problem. What do you do with them? You add them. What is 1/3 plus 1/3 plus 1/3? 1. So 18 to the 1st. Do I need to rewrite that? No, I'm done. It's just 18. That was a nice, easy one. All right, so the first thing you want to do is actually simplify them, pull them all down into like one base. So number 2. When you're dealing with something like that, you keep the base the same and you add its exponents. So it stays in 18. Just like on number 2, that's going to become 3 to the, what's 1/4 plus 1/4 plus 1/4 plus 1/4? Are you seriously typing that in a calculator, you guys? It's just 1. Oh, that was painful. Oh, that was painful. 1/4, 1/4, 1/4, 1/4. All right. All right, what about Now see, when they're common denominators like that, I expect you should add those in your head, right? So on number 3, it would become v to the 3/5. Now, guys, we don't want to leave things with a fractional exponent unless the directions specifically ask you to, like homework on Friday where I had you switching between the two. So I don't want to leave it as v to the 3/5. You want to leave your answers written in radical form. So how would I rewrite this? V to the 3rd. Right, underneath, growing under the ground are my roots, so my root is 5. Can I take a group of 5 from my v's? No, so I'm simplified. But we don't want to leave fractional exponents, okay, in a final answer. It's considered not simplified. Okay, number 4, a to the 1/2 times a to the 1/6 times a to the 1/9. What am I doing with my exponents? You're adding them. Now, if you're doing it by hand, you would have to get a common denominator. Can you use your calculator to add them? Yeah, your calculator will do the common denominator stuff for you. So what's 1/2 plus 1/6 plus 1/9? What is it? 7/9. You guys concur? A to the 7/9. Okay, so we put it all together, and then I need to rewrite that into radical form. So what root is this? Good, it's the 9th root of a to the 7th. Can I take a group of 9 from my a's? No, so I'm done. Now, if I could take a group of 9, then you'd want to. Number 5, 2 to the 3/4 times 2 to the 1/5. What am I doing with my exponents? You're adding them. So what's 3/4 plus 1/5? 19/20. 2 to the 19 over 20. Right, you keep that same base. Don't actually multiply those 2's together. Keep the same base. All right, so once we put it together, now let's rewrite that. What root? 20th root of 2 to the 19th. Can I take a group of 20 from there? No. Maybe today's not so bad for a Monday, right? All right, what about number 6? What do you do with those exponents? You distribute them. Good. What is 9 times 1/9? 1. So I have 27 for the first. Do I need to rewrite that? No. 27 to the first, you could just write 27. It's okay. Questions so far? Exponents only distribute to other exponents. Okay, so that's what we did. We just took the exponent to the exponent. So number 7, what am I going to multiply here? 5 times 4/5. What is 4/5 times 5? Is 4. 3 to the 4th. Could I simplify 3 to the 4th? What is 3 to the 4th? 3 times 3 times 3 times 3, which is 81. All right, number 8. What do you think we should do on that one? I agree with the 12 because we have just the big numbers, the coefficients out in front. It's a multiplication problem, so we actually multiply those big numbers. And it would become m to the, what is 1/3 plus 3/4? Remember, you would add your exponents because that's a multiplication problem. 1 1/2 does not convert to 13/12. Hold on. Okay, thank you. I'm like, that doesn't convert what you guys just told me. So 13/12. All right, well, let's kind of go, let's stop for a minute before we finish this one off. So we took the it's a multiplication problem, right? You had two things being multiplied. We multiplied the coefficients, the 6 and the 12, or 6 and the 2, to get to 12. Because there's no exponents on those, right? They're just coefficients. Then my m's are a common base. So we keep the common base, and it's a multiplication problem, so we add our exponents together. So 1/3 plus 3/4 Do we want mixed numbers here? No, we don't want mixed numbers. So it'd be 13/12. Now, if I rewrite this, because I can't leave fractions there, I need to rewrite that into a radical form. Does the 12 go under a radical? No, because its exponent is just 1. It's not a fractional exponent. Yeah, remember we talked about that one on Friday. And then this becomes, what's the root? 12. And it would be m to the 13th. Good. Can I take a group of 12 out of my m's? Yes, I can. How many groups of 12 can I take? Leftovers? Be careful the way you said that. I'm sure you wrote it correctly, but the way you said it was wrong. That'd be 12m times the 12th root of m. Don't just say radical m, because that implies square root. All right, are we okay? Multiply the coefficients to get 12. Add your exponents to get 13/12. We rewrote it. The 12 does not have a fractional exponent, so he does not go under the radical. We wrote the 12th root of m to the 13th. I could take one group of 12 out, and there'd be 1 left over. Okay, number 9. Ooh. Number 9. I've heard a lot of you flipping your paper. You missed one. What do you want to start with on number 9? Good. What is 36 divided by 9? 4. And then my d's, what do you want to do with their exponents? Good. What is 1/2 minus 4/5? -3/10. Okay, let's go one step at a time here. So that's good. We need to move that because we can't leave it negative, right? Does the 4 move? No, its exponent is a positive 1. The 4 stays, but the d is going to have to move to the bottom. Moving it causes it to change to a positive. Yes, that's a fraction. Yeah, that's a fraction. Yep, negative exponents takes whatever it is, move it to the bottom, make the positive. All right, I don't want to leave a fractional exponent, though. So I need to rewrite that in radical form. So it'd be 4 over what root? 10th root of g to the 3rd. Can I take a group of 10 from my d's? No. So am I good here? Done? I can't leave radical on the bottom. Yes. You need to multiply top and bottom by the 10th root of, Jessica said it. Do you guys see it? How many d's am I missing? 7. Right, because we can't leave the radical on the bottom. So now on the top we have 4 times the 10th root of d to the 7th, all over what happens to the bottom? Just d. Ooh, that just kind of took everything we've done in this chapter and kind of all put it all together. All right, but one step at a time, was it terrible? No, one step at a time, guys. Don't try to do everything at once. Yeah, it was terrible. Yeah. All right. So number 10 got a little ugly looking, right? So number 10, good. This is a division problem. What do you do with exponents? You subtract them. So I have m's. What is 1/2 minus 1/8? Try again. Be 3/8. And then my n's, I can put those together. What is 5/8 minus 1/4? 3/8. All right, m to the 3/8, n to the 3/8. Do I need to move any of them? No, because none of them are negative exponents, so that's okay. I can't leave them with fractions for exponents, though. Can they both go under the same radical? Yeah, they're both the 8th root. Yes and no. It depends how you write it. Because I can rewrite this would be m to the 3rd, and then n to the 3rd. So you can write it this way, which I'm guessing most of you probably would. If you want to be a little fancier with it, since they're both to the third, you could have written mn in parentheses to the third. I don't care which way you do it. I'm going to guess most of you would probably go here. Just because you're doing it one step at a time, you'd write them down. So either way's fine. All right, number 11. Be careful. Do you guys see some negative exponents sitting in there? Okay, just don't lose those negative signs. Again, let's go one step at a time, okay? So on my x's, what is 2/3 minus negative 1/3? You need those double signs in there, okay? You get what? Just one. Yep, just one. And then my y's, you have negative 1/4 minus 1/2. Negative 3/4. Then my z's, what's the exponent on this z? 1. So you have 1 minus 3. Negative 2. All right, so there was step 1. I just used my properties. I subtracted exponents to get to there. Do I have anything I need to move? Yeah, the y and the z both move. So x stays on top. Y moves to the bottom as 3/4. Z moves to the bottom, positive 2. I should probably write that 2 differently. I'm lazy. I don't want to write the 1. All right, anything else I need to rewrite? Yeah, the y. I can't leave a fractional exponent. Okay, so the z squared's going to stay. He's okay. How does... There you go. It's all right. All right, so x over z squared, 4th root of y to the 3rd. Good. Can't leave that. 4th root of y to the... just y? Yeah, I already got 3 out. I need 4, so I'm only missing one of them. So x, 4th root of y. Y z squared. If you would like to write z squared y, it's not wrong. I like alphabetical order. But they got flipped when I wrote them before because one was under the radical, one wasn't, so I threw it out in front. So it just kind of messed with you a little bit. All right, number 12 is a bit of a doozy. Try it on your own first, and then we'll go through it. Okay, so give it a try, see what happens. All right, well, what is the first thing you should do on this problem? Good, you should distribute first. So if you didn't distribute first, that'd be your first thing that you did wrong. Okay, so we need to distribute this little 2. Does it also go to this 2? What's the exponent on the 2? There's 1 here. It absolutely distributes to that 1 exponent. So it becomes 2 squared. And then when we distribute to the a, what is 2 times 3/4? Be 3 over 2. And then 2 times negative half, negative 1. Does it distribute to the bottom as well? No, it only distributed to what the parentheses were around. So the bottom is still here. A to the 4/3, bless you, c to the 3rd. Okay, so that was step 1, distributing. Did anybody actually distribute it to the 2 like you were supposed to? A couple of you? Yeah, it goes to every single piece. Now, it goes to every exponent. So, I mean, we had to recognize the exponent was just a 1. Remember, it's not held with a plus or minus. We piece everything out one piece at a time. Because I multiplied 2 times 3/4. All right, so cleaning this up a little bit, 2 squared is 4. And then what am I going to do with my a's? Subtract. What is 3/2 minus 4/3? 1/6. So a to the 1/6. Negative 1 minus 3 would be negative 4. Okay, then we have to move that to the bottom. So 4, a to the 1/6. The negative exponent is going to move that c to the bottom. Good, good. Now fix this. I can't leave the fractional exponent. Does the 4 go under? No, 4 stays out. And then we have what root? Go to a to the first over c to the fourth. Do I need to rationalize? No, and I'm done. Just the 2? Okay. Good. Okay, that's not bad, though. That was a little trickier one. I'm glad you guys seem to do okay. All right, here is the game plan. What's going on today and tomorrow. Homework for tonight, due tomorrow for a grade, is the back side of the worksheet that we went over today. Right, we only had done the front side. So homework tonight is the back side of that. Also, you saw I just hung up the purple scavenger hunt around the room. We will start that today. If you don't finish it, that's okay. Just hang on to it. When you come in tomorrow, we'll go over homework. I'll give you time to finish the scavenger hunt tomorrow. But then you also have another assignment tomorrow. So I'm being nice here. I'm giving you time, okay? Relax. So I want to make sure you're aware. So don't be like goofing off the whole time, right? Like utilize your time. So if you would like to work on homework and get that done first before you start scavenger hunt, that's fine if you want to do that, as long as you're working. If you want to start scavenger hunt for at least a little while, making sure you're okay, and then switch and do the homework, it's up to you. Okay? But I'll pass out the papers for scavenger hunt. But keep in mind, tomorrow when you come in, we'll go over homework and then finish scavenger hunt if you didn't finish it. And then after that, you'll have another assignment to be working on in class. I want to draw your attention real quick back there above Ramon to letter S. Nice, Ramon. At the very top, it says, if you got, Ramon, does it say anything, if you got? Yeah, for whatever reason, when I printed it, it like went right back to like size 12 font or 10 font. It's really small. So I don't want you to be thrown. There is an answer written there. It's just written really small for some reason. Okay? Make sense? Are we good? Questions on what's expected? Yes, you may.